Now let's discuss a few more string functions. The first one we are going to discuss is match. So these were not discussed earlier because these last set of methods, they use regular expressions in some matter, and now that we are aware how regular expressions work, we will better understand them. So let's start with match. This is a method on a string which is used for matching a string against a regular expression. So for example, let's say there is a string and on that I do, let's say, dot match, and I provide a regular expression. Then it will return that that the first match which this regular expression is going to match in this given string. So we can clearly see that hello is the first one which is matching this regular expression, and that is returned. And we can clearly see that it is matching at index 5. So as you can see that this is almost equivalent to execute exec method which was available on regular expressions. Just the difference is that there regular expression dot exec, and that string was passed as an argument. Here string dot match and regular expression is passed as an argument. Okay, but both provide the completely identical results. Next, this is just a trivia that if you should always pass some regular expression in the match. If you don't provide any regular expression, then an empty string match is returned. So that is just the fact of this match function. Next, we can also use g flag when this regular expression is provided. Then in this regular expression we can also use g flag. If that is used, then only the first complete match and its related capturing groups are returned. Okay, let's say this thing is there. It has two matches for this regular expression. So this HELO will also match, and HELO both will match, but it will only return the first match with this string. We also have a match all, which we'll see later. But right now we can clearly see that an array is returned where all the matches, where the first is the complete match, and after first match all the remaining elements are basically the capturing group. So here we can see that the capturing group is this EL plus. So EL, the first HELO, the EL is the match for this capture group, and that's why that is returned. Now, if the G flag is used, then all the results matching the complete regular expressions will be returned, but capturing group will not be returned. So last we saw that when this thing is used, then G flag is not used, right? So the idea is that you can provide G flag, you can not provide also G flag. But if you don't provide G flag, then that is basically a complete first match, and all the other capturing groups all are returned. However, if we provide a G flag, then only the matches, no capturing groups, only the matches are returned. So here you can see that the two matches HELO and HELLO both are returned, but the capturing groups are not returned. Okay, now if you want to return capturing groups also, then we know that we have other exec method on regular expression that we can use, or there is also another method called match all, which we will see soon. So this is what a match all is, that it returns an iterator where all the results with the capturing groups. Okay, all matches with capturing groups all are returned. So and here the provided regular expressions must be must have G flag. If you don't provide G flag in this G flag regular expression without G flag, then match all will give you error. Okay, so let's see. Obviously we have to provide G flag. Now when we start this match all method on a particular string, then what will happen, that this results will contain all the matches and all the captured groups, but you can clearly see that it returns a iterator. So if you simply console log, you will not be able to see all the results. So there are two ways: either you can iterate over it, or you can convert this iterator into a array. And if you do that, then here we can see that if we convert this iterator into array.from, and this, and then when we pass iterator, then it is going to convert this into an array. And let's see, this is the array. So it is basically an array of arrays. Array of arrays. Why? Because there might be multiple matches. Okay, even if there is one match, then also it will be an array of arrays. But the idea is that there will be an array, and it will have all the matches as arrays, where each array will have for that particular iteration the match and all the capturing groups. So here we see that in the first round, HELO will be matched with, and the match is HELO, and the capturing group is EL. Okay, and next we will see HELLO, and the capturing group match is ELL. So we can clearly see this. However, this is like converting iterator into array. We can directly iterate over this also using we earlier saw that we could use for off, right, easily for this. So when we iterate over this iterator, then if we console log, let's say every time the result, then it will print out all the items one by one in that iterator, and we have already seen that these are the items in this iterator. Okay, and also note that these matches, they are not restart the match, the iterator which we are getting finally as a result of a match all, that is not restartable, right? So let's see. So let's say there is a string, and let's say that is HELO and HELLO. It has two things, and then if we do let's say match all, and we provide some regular expression which is matching, let's say HEL plus O. Okay, then obviously this result is an iterator, and then we can iterate over this result which is an iterator. And let's say if we console log this, okay, so it is saying that it has to have a regular expression. So yeah, we earlier discussed that it must have a global expression, right? So we will later see that replace all, match all, anything which is, so basically why is it that? Because it is confusing, right? We are already saying that this thing should match all. Then if it should match all, then global flag means what? The match the whole thing. Then this is conflicting, right? And that's why in match all, replace all, which we'll see later, in all those things global flag is needed. Anyways, so the point which we were discussing is that it is not restartable iterator. Now you can see that yeah, this at index 5 and index 10 HELO is there, right? Okay, so these values are printed. So let's just write something like this, and we can clearly see this thing. Now let's do one thing, that firstly let's let's get a array from this let's get an array from this result, and let's print that, which we saw that is one way, right? Now if we do that, you can clearly see that now this is printed. If for proving that this is print for this is printed, but now this thing is not printed. Why? And that is the point of saying that this is not restartable. So this iterator which is returned, result, that thing can be iterated only once. So when we converted an array from this iterator, then already this is used iterated one time. After that, even if you iterate over it, it is already exhausted. All the elements have been iterated, so it cannot be iterated. So if you comment this, then only you can iterate it. And again, you can iterate it only once, which means that if you try to again iterate it, then again it is not possible. Only one time it is iterated. You see, this second thing is not iterating. So that is the idea of a non restartable iterable. So that is the result which we get from match all. Next, we'll see replace. So replace returns a new string with some or all matches. So what happens that we provide a string, and on that string we can do dot replace, And then when we do that, then the original string is not modified, a new string with the all the replacing is done, and then that string is returned. And the pattern which we want to replace, that can be a normal string also, that can be a regular expression also. So if the pattern is string, then only the first occurrence will be replaced, right? So let's say this thing, we want to replace hello with Ola. So hello, hello, at two places we see hello. But when we replace, then we will see that only when we console log this whole expression, then we will see that only the first instance of hello is replaced, and second one is still hello, right? It is not replaced. So actually replace, there is another method, replace all, which we can use for these things. But the point is that in fact we can achieve replace all using replace also, using regular expressions. But let's see, if we do some like this, some regular expression, hello, and this regular expression is provided instead of a string, then we are going to see that still the first instance is only replaced, right? So that is fine. But either if you want to replace only the first instance, you can either use a normal regular expression or a string, both will work. But if you want to replace all the instances, then using strings it is not possible, but in replace method, but you can pass a regular expression with global flag, right? If you use that, then whatever this regular expression is matching, wherever, everything will be replaced by the second parameter which you are passing. So this ola, hello, everything, everywhere hello will be replaced with Ola. Okay, so you can see that both instances are replaced. One more thing, while we are doing that replacing, the second thing is a string. We saw that, right? The second argument is a string, which is like what has to be replaced. But that can have some special things like $n, where $1, it means like $1, $2, $3, like that. It can be there. What it means is that if there are capturing groups in the regular expression, then this $1, $2 will in that order represent all the capturing groups. So for example, let's say this is a regular expression and you do dot replace, okay, and then let's see, yeah, so 3 digits and then 4 digits, all separated by hyphen. So and it should start and end, nothing should be before and after that, right? So we can clearly see that 3 digits and 4 digits, right? So it will match. But more importantly, you can see that we have three capturing groups here, one here, one here, one here, which means that on the 3 digits and the 4 digits, all three capturing groups, there are three capturing groups. And this is what I meant by $n, that $1 will mean 1 to 3, $2 will mean 4 5 6, so whatever is captured. Now you can use those dollar symbols in the replacer string. So if this is the thing which we are going to replace, then $1 will be treated as 1 to 3. So you can see that I am writing that replace this with $1 dot $2 dot $3. But this $1 is now replaced with the first capture substring. So that is 1 to 3, right? And that's why the answer is 123.456.7890. Okay. Next, take an example. Let's say there is a full phone number or something and we want to hide a few numbers, right? Then we can write something like this, that yeah, this thing is fine, $1, and then you can write XXX and then $3, which means that $1, $3 is available and $2 I'm not using, instead I'm using XXX. So in that case we can create a masked phone number like this. Next, the replacement can also be a function called for each match. Okay, so this thing is basically a string right now. However, you can provide a replacer function also. Rather than a replacer string, you can provide a replacer function also. And if you pass that, then what happens is that this replacer function will have something like this. The first one is match, okay, and then P1, P2, P3. So what happens, that first one is match. Match means whatever, like every time, so for this iteration, what is the and this is not replace all, this is simply replace, which means that only one time match will happen, and the first instance whatever is matched, and in this case the whole thing will be matched. But what is the match? The match is the whole thing, right? And p1, p2, p3 are identical to $1, $2, $3, right? So whatever the capturing groups are there, if you directly use a string here, then you use $1, $2, $3. However, if you use a replacer function, then from second arguments onwards, you can name this anything, x1, x2, a1, a2, whatever you can name. But the point is, the first one is the whole match, and after that, whatever is the number of capture groups, that many arguments, further arguments will be there, which will be for captured substrings for that capturing group. And then some more things are there, which you can print. You can capture at rest as rest, and you can print that. But the point is that that rest will have something like at what index it is matched. In this case it is 0, and in this case it is not 0, it is basically, you can see that 0, 1, 2, 3, 4, 5. Yeah, so this will be like 0, 1, 2, 3, 4, 5, 6, 7. It will be 7th index. So this rest will have this 7 index, and it also has the whole string on which it was called. So those things will be available in rest. The main important thing is that match will have the whole match, and p1, p2, p3, and if only one capture group was there, then only p1, and then the rest will be there, right? So whatever is the number of captured groups, that many arguments will be available. Okay, now you can see that I can also do replace all sort of thing. Okay, so which means that I don't want to replace only the first instance, I want to replace all instances. Uh, Here we can use normal regular expression also, and regular expression with g also. If we use a normal regular expression without g flag, then only the first instance will be replaced. If we use g flag, then all instances will be replaced. However, there is another function which we'll see next, is replace all. And again, the rule applies there also, that in replace all we have to use again global flag only. We cannot use any regular expression without global flag. Okay, so let's see in this case what it is doing is that HELO. So both of these are matched. So replacer function will be called, this is match all, so it will be called multiple times, one time for each iteration. So let's say HELO is matched, then this will be called that time. HELLO is matched, then this will be called again one more time. Every time it is matched. And what this HELO will be replaced with, that is basically returned by this thing, returned by whatever is returned here, that will be basically replaced with this hello. So you can return anything, whatever you return here, that will be replaced with the matches. But in this case we are using replace again inside. Why? Because let's say we want to replace whatever is the match, we want to concatenate it with extra l. So in this case, we will see that HEL is there, and then that EL, okay, EL is the one which is going to be matched here, right? Now if I do match dot replace, then what will happen? You see that EL, I am saying that EL should be replaced with EL plus L, which means ELL. Okay, so I am saying that match dot replace, which means that hello dot replace, and then replace EL with ELL, and that's why you see that here HELL is there. And similarly here what will happen is that the first EL will be replaced with ELL, and that's why instead of 2L there is 3 L's. Okay, so in that case, if you need some complicated logic inside your replacer function, then this sort of syntax can be used for advanced replacement. For normal replacement, obviously simply having a string here will suffice. Now, as we were saying earlier, replace all is another thing. And again, we could have done replace all with, we saw that global with G flag, if we provide a regular expression, that can also be used. But now this is like simpler to use, because we, even without regular expressions, we can achieve that same thing. So we simply say that this thing dot replace all, and both are strings, simple strings. So hello replace with Ola. So this is like simpler way without the complication of regular expressions. Regular expressions though are more powerful, but it might be slightly tedious for beginners, right? So this is a simpler method which was later added to JavaScript, where you can simply do replace all, and that will be achieving the same thing, which you could also replace using regular expressions, global regular expressions on replace. Okay, but here replace all is a simpler method. Now you can do that same thing here also, that instead of string you can use global regular expression also, but then if you do the same thing with replace, that will also works fine, that will also do the same thing, right? And here there is additional restriction, that replace all can only be used with global flag, it cannot be used without global flag. Okay, so that restriction holds here also. Okay, so yeah, that is fine. Let's see the next one. This string, and we do replace all hello. Okay, so yeah, you see that we are saying that this is replace all, and then we are not providing g flag, and that's why this is giving us error, right? So the better way, the simpler way will be always use replace if you want to do simple first replacement, and you are using only strings. If you are using only strings and you want to replace everything using normal strings, then you simply use replace all. And the third rule should be that if you want to use regular expressions, then always use replace, because whatever the regular expression behavior is there for replace all, that same behavior will be for replace also, because anyways g tag is compulsory here, right? G flag is compulsory here, right? So for regular expressions it is simpler to use only replace rather than replace all. Why? Because that will work for normal regular expressions also, where it will replace only the first instance, and that will also work for g flag also, where it will replace all the instances. Okay, let's take an example. So this thing dot replace all, and I'm saying that yeah, so capture, so match 3 digits followed by hyphen, which means that 1 2 3 hyphen 4 5 6 hyphen, these will be replaced, and what is captured? The captured thing is only the digits. So 1 2 3 and 4 5 6, these are captured, right? And we are doing $1 dot. So basically what is happening is that I'm saying that replace 1 2 3 hyphen this thing with $1 dot, which means that whatever is matched. So here there is only one one only capturing group, and that's why $1 is the only one which makes sense here. Replace it with $1 dot, which and $1 will be whatever is the match. So first time match is 1 2 3, and that's why first time this thing 1 2 3 hyphen, this thing will be replaced with 1 2 3 dot. Second time, since it is a global match, so it will keep on replacing everything. Second time 4 5 6 hyphen will be matched, and it will be replaced with 4 5 6 dot. So here 4 5 6 dot. So you can see that you will get this thing, something like 1 2 3 dot 4 5 6 dot, and then 7 8 9 0. Okay, and you can also do something like this, where you can use 1 2. So let's say let's take this an example. So let's say I have what is there? Let's say 1 2 3. Okay, and on this we are going to do replace all. And what we are going to do, since this is replace all and we want to use a regular expression, so we will use some global regular expression, which is yeah, we want to capture the digits. Okay, and it should be a global, and that there should be 3 digits, and there should be a hyphen after that. Yeah, and what we want to replace it with, we want to replace it with $1 dot. Okay, it looks like instead of the D, it should be G. By mistake I wrote. Yeah, so yeah, so the point is that yeah, so $1 dot. Okay, so let's see. Yeah, so I'm doing some mistake here. Yeah, so basically what has happened is that I have used this additional thing, right? see, from here till here, okay, this part. You can see. So what was happening is that the brackets were misaligned. So the first thing which is this being captured, right? This thing is a group, right? This thing is a group, and this next bracket was for replace all functions, which was misaligned. Anyways, you can clearly see that 123.456.7890. Now this thing is replacing, and you could do something like this xxx hyphen, and this will hide the three digits, right? And only the last four digits, which is not matched by this regular expression, that will be printed. So we can clearly see that something like this is happening. Now, why I'm taking this example? Because in replace all also we can use a replacer function here instead of this normal string, and that normal string has the capacity to use that $1 those facilities also. But apart from that, the replacer function is also possible, where if we have, let's say, some replacer function, and we discussed earlier that, see, one thing you can use instead here, you can use this replacer function. And what we discussed that we have match, and then here only one capturing group is there, right? That's why P1, and then everything will be captured. So I'll also show you that what is this match and what is this rest. But right now let me just simply show this thing. Let's say I return simply xxx hyphen. What will happen? So you see the answer is same. So what is happening, and you can do anything, let's say abc hyphen. So see, what is happening is that I'm saying that you replace all with every match. You call this replacer, and whatever is returned, you replace that match with that thing. So I'm saying that the first match is abc hyphen. Replace abc hyphen with abc, replace 123 hyphen with abc hyphen. Second match is 456 hyphen. Replace 456 hyphen with abc hyphen. Okay, so that is what it is happening here. But now we have these arguments also, right? Let's print them to see what are those. Firstly, let's see how many times it is called. So let's say I'm printing arrow. We can clearly see that 2 times it is printed, which means that 2 times it is called. And why 2 times it is called? Because 2 times we are matching. First time we are matching this thing 1 2 3 hyphen and 4 5 6 hyphen. So you can clearly see that the replacer function is called each time a match is there. That is the first thing. Second, let's see what is match. What is match? What is P1 and what is rest in each case? See, we can clearly see that the first time match is 1 2 3 hyphen, and that's why this 1 2 3 hyphen is printed. And what is the captured group? The captured group is only digits. So the P1 will be basically 1 2 3. Next, whatever rest things are there, that is captured in rest. Okay, so you can clearly see that most of the times you will not use it, but if you need the index where it is matched or something, then you can find that, yeah, it tells me that 0 is the index where this first match is happening, yeah, here. And then 1 2 3 4 is the index where this second match is happening, so 4 is there. So and again the whole string on which this thing is called, that is also provided as additional argument if you need, in case you need it. But yeah, but the main point is that now we understand that what is match and what is P1, right? So now we can make use of those things here. So something like this, I can use match dot replace, and then I can, so earlier whatever we were doing, right, we can do the same thing here. So this match is a string, we know that. Since it is a string, so I can do replace. And you can see that sometimes IntelliSense is not working because JavaScript is not aware always that this match thing is a string. But anyways, what we are trying to replace it with, we are replacing that in this 1 2 3 hyphen, replace 1 2 3 with, let's say, xxx. And what is 1 2 3? 1 2 3 is P1. So I can say that P1, replace P1 with, let's say, xxx. Okay, and then I will get the same answer. Okay, that is the first thing. Second thing is that why we need this replacer function? Isn't the normal thing which we earlier did, right? Like something like this wasn't that sufficient? So something like this we were using, right? What we were using? We were using something like $one hyphen, right? So this, and for if we don't want to if we want to put exactly, and we can put xxx hyphen if we want to really mask the numbers, these numbers, right? Oh yeah, that works. But let's say your requirement is slightly advanced. Your requirement is that let's say something like this, that it can be 2 digits also, it can be 3 digits also. Yeah, 4 digits you don't have to replace, but two digits hyphen and 3 digits hyphen both you have to replace. Let's say, then you can write something like 2 comma. So obviously now 2 3 hyphen will also be matched, and 4 5 6 hyphen will be also matched, right? Because there can be 2 digits or 3 digits, both is possible. But if you see that if you now run it again, it is triple x hyphen. Okay, because we are replacing it with triple x hyphen. So how do we know that this thing is 2 digits, and that's why we have to replace it with 2x, and this thing is 3? There's no way to know here, right? If you use 3, then everywhere 3 is there. If you use 2, then everywhere 2 is there, right? Yeah, so this is trouble. We can do one thing, that we can use yeah, we can get the we can do a 2 digit replacement, and then we can do again one replace all with 3 digit. So we can write the whole thing twice, right? One time with 2 and one time with 3, right? And we can replace one time with xx and one time with triple x, right? And again we need to replace whatever is the output is there, that I have to put it here in order to get. So that can be done, but again we can clearly see that that is complicated. The purpose of using replacer function is that only, that it is powerful. It is powerful because you can write your whole complicated logic here in order to do these sort of sophisticated things. So for example, here I'm replacing I'm replacing everything with triple x. Yeah, that is fine. But now this is a complete JavaScript function, and you can write your custom logic here, right? So I know that my thing was so let's change here also, do something like this, 2 comma 3. Okay, and now 1 2 3 hyphen and 1 2 3 2. But now if I run, then I see that the first match is 2 3 hyphen, and the captured thing is 2 3, and the second match is 4 5 6 hyphen, and the captured substring for the captured group is 4 5 6. Since and I have everything in all the pieces of information here, which I can use to do this, which means that if P1, this P1 is 23. If P1 is 23, right? If P1 is like 2 digits, then replace it with 2x. And if P1 is 3 digits, then replace it with 3x. That is our requirement, right? And then everything will work fine. For that, I can do a simple thing called, we have already seen a repeat method, right? So string dot repeat, and then I can say that whatever is the length of P1. So P1 dot length, right? And now I'm saying that if I am repeating x, that many times whatever is the length of P1. And now you can see that you have got this thing, that when 2 digits are there, then 2x is coming, and when 3 are coming. So if both are 3, then it will be like 3, and if both are, let's say, 2, right, then it's 2. Now we have written our custom logic to dynamically handle that, right? So these sort of advanced situations where you might need these things, then replacer function is very much helpful. But for normal scenarios, simple string replacement will work very much fine. Okay, next is search. So you can think of search like index of. So we have a method also, index of, right? So let's say there is a string and I want to find where is hello. So earlier we had a method, right? Like string dot index of and hello. I can find that where is hello, and if that was found, then it will return the index of that, the starting index of that found substring. And if it cannot be found, whatever we are searching for cannot be found, then -1 was returned. You can understand the regular expression version of the same index of sort of thing here. So what it does is that it is not searching normal strings, it is searching for regular expressions. It returns the index of the first match, first match. Like index of was also doing first match only, right? So here also we can find the index of the first match between a regular expression and a given string, right? Rather than a provided substring and a provided pattern whatever, and within a string. Rather than that, we are that pattern is not a normal string, that can be a regular expression in this case. And if we cannot, that regular expression cannot be found, then -1 is returned similarly. So you can clearly see that what is the advantage now. So if we use index of, then I have to know the exact string which is to be found. But let's say I don't want the exact string to be found. I want some pattern to be found again and again. So let's say my pattern is HEL plus O. So one or more else should be there, which means that I want to find the first position of this pattern. So you can see that the first position of this thing is here, the first position of this thing is here, and this thing cannot be found in the third string, right? So rather than so this sort of dynamic thing where like multiple things has to be matched, so again the power of regular expression will come in that case, right? And that is where this search function comes as helpful. So right now, rather than index of, because we are not aware, like it can be HEL also, HEL also, we can create a regular expression for all our needs, whatever pattern we want to match. And then rather than doing string.index of, we will do string.search, and it will return equivalent answers, but it will handle regular expression also. So for example, string1 dot search re, then it will search for this regular expression. Yeah, the first match is found here, it will return 5. Yeah, 5 is the index. Again you do the same thing, dot search re, the same regular expression will match here, but now it will match HELO, because this is a regular expression which is accounting for 1L 2L both, right? And that's why again this will also match and return you the index where that is found, so 5. But if you run the same thing on str3, then this pattern is not found here. So like index of, it also returns -1. Okay, so in that case, this is just a more powerful version of index of. Split. Now split we already saw, right? We already saw that it splits a string into an array of substrings, and let's say this thing is there, and I was splitting it via L. Then yeah, the first part will be O, and then this L is coming, right? So the second part will be from A till this E. So A till this E. And again there are 2 consecutive L's, so there will be another 1/3 empty string, and then again we will start with OA, and then again L is coming, and then EX exclamation mark. So these are the array of substring. This is an array of substring which is found as a result of splitting this string with a divider which is L, right? But the fact I am discussing it again here is that this thing can be a regular expression also. Now that we know regular expressions a bit, so you can try this with regular expression also. So something like this. So string dot split, and the same behavior can be achieved like this also. So there is a regular expression which should match L, only L, right? And then you can match it with you can split based on this regular expression, and then again the exactly same answer will come, right? And again, if you let's say you wanted to split it with LL, then let's say in a string you will provide LL. Similarly in regular expressions also you can provide LL. Okay, that is fine. But the power of regular expression comes that what if I want to split based on L also and LL also? Okay, what if I want to do something like that? Then I can do something like this, that since this is a regular expression, I can create a full-fledged pattern for my desire, right? So let's say this is L plus. Now this means that it will match one or more L's. So this L will also match, and this LL will also match. And note that since this is L plus, so the divider here is not L, here divider is LL, and that's why wherever L is there, that L will act as divider. Wherever double L is there, that double L will act as divider. So in this case we will see that L is there, so L will act as a divider, and then A to HE, right? And then after that, even if double L is there, that whole double L is matching with regular expression, and that's why that whole double L is acted as our divider now. and that's why this empty string is not coming here. You can see that directly now OA is coming, and then again this L is matched with regular expression, and then last part is EX. Okay, so if we want advanced sort of splitting, then we can use, instead of a normal divider, we can use regular expressions as this delimiter, and we can achieve the same thing. Okay, so that will be all. So these were just a few methods which I did not discuss earlier because they involved some regular expressions. So now we have learned regular expressions, and now we have learned the rest of the methods which we wanted to learn on strings also. So this concludes almost all the methods which are available on strings. Okay, so that is it for now. Let's see you in the next one.